Okay, so I'm pretty excited to be talking about this ontological proof business. I'm kind of at the end of my investigation now. And so it all started like this. It's kind of interesting. So we have this person is called Anselm of Canterbury. Okay, so they were around a long time ago. And I got these slides from this person called Elke Brendel. Anyway, I knew about this story before these slides, but these slides really helped me understand the final argument. Okay, so basically, um, let's see what it says here, and it's obviously a translation or some sort, probably, or maybe this is English. Okay, so therefore, even the fool is bound to agree that there is at least in the understanding something that than which nothing greater can be imagined, because when he hears this, he understands it, and whatever is understood is in the understanding. And certainly that then which a greater cannot be imagined cannot be in the understanding alone. For if it is at least in the understanding alone, it can be imagined to be in reality too, which is greater. Therefore, if that which a greater cannot be imagined is in the understanding alone, that very thing than which a greater cannot be imagined is something than which a greater can be imagined. But certainly this cannot be. There exists, therefore, beyond doubt, something than which a greater cannot be imagined, both in the understanding and in reality. Also, it is a translation. Yeah, so this is not the version I heard, but if I read this, I think I can understand why some people might have some problems with it. But sort of the simple version I heard, right, was basically tried. It seemed someone else helped him say it, maybe. But if you define God to be sort of this being which nothing greater can be conceived. So all the great, like everything is as great as possible, and it's all possessed by this being, right? Then what he's saying is, and then this being exists in your mind. So sort of whatever this being is, sort of at least the concept of it, you can imagine it, right? And then he's saying, well, if it's only the concept of this being you could imagine, then it would be even a greater concept or a greater thing if it actually existed as well. Okay? And so therefore, because it can't be any greater, it must have included this extra thing which was existing in reality. Okay? So the thing is, a lot of people, so it's a very interesting argument, okay? And I guess a lot of people didn't give it the credit it deserved. So I guess the point of this is not to say whether sort of God exists or not, because it's way too early for that. It's more just to investigate what the argument actually means, you know? And it really brings up a lot of interesting questions because, like, can you make so is existence just like a property of something like everything else is? You know what I mean? If something could sort of exist abstractly and then be proven to exist concretely by just attaching a property, you know? So that's a very interesting idea. But if you read it like this, in this quote, therefore even the fool is bound to agree that is at least in understanding that which something nothing greater. So you can understand. So one of the first objections was by this guy called Guanillo, okay? And what they basically said was, you're saying, like, he's basically interpreting the argument like, if you can imagine something, it can't only, and that something is really great, or maximally great, then it should also exist. So then he went on to say, well, if I said that there was a greatest possible paradise, a tropical island, okay, and I can imagine the existence of it in my mind, but such a tropical island would be even greater if it existed, okay, then therefore it exists, because it can't be any greater, and it would be greater if it existed, so it must also exist, right? And people saw that as, you know, as winning the argument and triumphing over the original argument, okay? And then Granillo, it felt like, got a lot of credit for it. And there was a lot of holes poked into the first argument. Okay, but I think a lot of it just comes from the fact that these things are worded like this. So it's worded in such a way that makes you think he's actually saying, if you can imagine it, then it actually exists, and that's obviously not true, right? But if you look at the way you argue for which a perfect tropical island exists, right? And you do repeat the same argument, then you're actually just proving the existence of this godlike thing and then naming it a tropical island. So that's not really um, an objection to the proof, because once you realize it's a tropical island, once you name it a tropical island, you're tempted to think of it as a tropical island. When you think of it as a tropical island, it becomes really confusing, okay? Because actually, the greatness, the maximal greatness of this being, okay, is sort of unconditional in some sense. It has all the greatness attached to it. It doesn't have this greatness amongst tropical islands idea, which can be quite complicated. Okay, anyway, the moral of the story, as far as I can see for that, is that there's a lot of things wrong with Anselm's argument. In a sense, it's not stated precisely. It doesn't really make too much sense if taken literally, or how do you even take it literally, or what does it even mean? But there's actually an underlying idea that's really great, and that's something people really miss out on when they take people's logic apart. Okay, because logic is either true or false, right? It's true or false, but an idea can be interesting even if you apply it wrongly with logic. And that's something that you'll learn if you do a lot of mathematics, because people make a lot of mistakes. Okay, there are people that always make statements which are sort of technically wrong, but they're always on the right track because they have the right idea. And so this idea of sort of trying to attach existence to something that has all these nice properties is actually a really good idea. Okay, and this is sort of where the direction we're going. Okay, and I didn't really take note of this until I heard about someone say like Leibnitz. Okay, so Leibniz is someone who takes this idea and tries to make it even more precise. So I think, was it Leibniz? It's this idea of a perfection. Oh, maybe this is an objection. No, okay. Was it Leibniz that had another perfect? Okay, and then I heard somewhere, so it was like, then they had this idea where it was like, God is defined to be a being which possesses all perfections. Okay, so that's like, what is a perfection? Okay, so then a perfection, I guess it's taken to be something that's a basic property that doesn't have a definition. Okay, it has all the perfections. Okay, and then existence is a perfection. Okay, and so therefore, if it has all the perfections and existence is itself a perfection, right, then it must exist. So it's trying to be a little bit more precise, but we still have a lot of problems because we still don't really have an idea what perfections are. Okay, and we still don't have an idea of whether it's even possible for something to have all these perfections. Okay, so in some ways, I think they're saying it's assuming that it's possible to have these perfections in one place. Okay, and then if it's possible, then a being exists with all those perfections. Okay, so it's just kind of like, yeah. So if you can't, and it's not easy to latch onto the idea, right? Because it's so imprecise. You might not be able to latch onto the idea, but sort of, I guess, if you try to latch onto the best possible idea that's here, then it should be this idea of having some being that possesses all these good properties, and somehow existence ends up being a good property, and therefore the being ends up existing. Okay, and so I didn't really notice this argument Well, I took a little bit of note, but I didn't really like get really interested until I saw this Gödel, mentioned. Okay, because I remember studying a course on logic, and I was studying one of his really great achievements. It was called Gödel's incompleteness theorem. Okay, so I remember, like, on the train in the morning, in the really early morning, just reading his notes. This was when I was first year uni, and he came up with some really like interesting mathematics and logic, and he decided to do something with this argument, and so that made me really interested in seeing what he was actually doing. Okay, so what he did was, instead of perfections, he changed the name. He called it positive property. Okay, and then he tried to make it more precise. So in the first axiom, he says, so you know what a property is. So a property, I guess, is, for my understanding, is like a logical statement, right? So a property, something is either yellow or it's not yellow, right? And then, so for properties are things for which you can determine for sure if something satisfies the property or it doesn't. Okay. So like, if your age is greater than 30, so you're either greater than 30 or it's not greater than 30. Okay, and that should apply for everything you're talking about. So then, out of those properties, a property is positive. Okay, and we try to define what it means to be positive. Okay, so if we have a notion of positive, then a property is either positive already, okay, or its negation is positive. Or another way of saying that is, so if the negation of a property, so like being over 30, the negation of being over 30 is not being over 30 or being under 30, right? The negation of that property is positive, is equivalent to saying the property is not positive. So another way of saying that is everything is either positive or not positive, okay? Okay. And then you have this thing where it's like, every time you have a positive property, okay, and then you have another property which is implied by the positive property for everything you're talking about, right? Then the consequential property is also positive. So that kind of is a reasonable sort of property to have for something positive. If something's good, then all of the consequences of it are also good. Yeah, that's kind of what it's trying to get at. And then it defines godlike property. So what godlike is defined to be is, it's if something is godlike, right, then all the properties, if that property is positive, then your thing satisfies that property. So being godlike means it satisfies all the positive properties. Okay. And then another axiom is that having all positive properties together is actually a positive property. Okay. And then there's some other kinds of modal logic that this works with, but so basically, Godel gives these axioms for what it means to be a positive property. Okay, and actually from these axioms you can prove not only these properties exist, positive properties exist. Okay, that not only do they exist, there also exists something that's godlike, which satisfies all these positive properties, and then another consequence of that is that thing is unique as well. Okay, and this is very interesting because the proof basically works. Okay, but you have to be careful, like what you're actually proving. Like we're not actually proving God exists here. Okay, these things are just called godlike, and these properties are called positive and stuff. But we have to be careful what it actually proves. So it's very interesting because it's saying that actually the original argument, in some sense, actually works, right? So all the sort of logical fallacies people were picking in it weren't sort of, I guess, the right kind of objections to the argument. It should really be an objections to the assumptions as opposed to an objection to the argument. Because once you have these assumptions, you can basically prove that this godlike being exists. Okay? And learning maths, this becomes really interesting for me even more when I see that so when you translate this thing to sort of sets, okay, So when you have logical statements, you can translate everything to sets. Because, so for example, you have one big set, okay? And that could be the set of sort of all the things that we're talking about, okay? For every logical statement we have on that set, we can break that set into two different sets, right? We can break up the set into the set for which the logical statement is true, and we can break it up into, and then the other set is for which the logical statement is false, right? So on one hand, we have all these statements, and on the other hand, we have all these subsets that correspond to the truth sets of all these statements, okay? Okay. So it corresponds to the truth value of all these statements, okay? And basically, if you replace the statements with sets, okay, and you replace, and you look at what the positive property corresponds to along the sets, okay. So here it's saying basically, if you have more than one positive property, if something satisfies multiple positive properties, the property of satisfying those combination of positive properties is also positive, right? So what that means is if something is in one of the sets and another set, if it's in both sets, okay, then it's also true for the intersection of the sets. So when something's in both sets, it's true. It's you know what I'm saying? When you have two sets, you have an intersection. It's in both. Okay, so that intersection set also corresponds to a statement, and that statement's also positive. Okay, so these properties all translates into some set properties as well. So the fact that if a property is positive, then all the consequential properties are positive, is just saying that if a set corresponds to a statement from a positive property, then any set which contains it also corresponds from a statement of a positive property. Okay? And then sort of being godlike is a positive property is basically saying the intersection of all the sets, that intersection corresponds to a statement which is also positive. Okay? And so the interesting thing about those properties when it's done on the level of sets is that they define a mathematical concept that already exists. Okay, it's called an ultrafilter or a principal ultrafilter. Okay, and then if you look at this argument from the perspective of a principal ultrafilter, it actually makes it really obvious, at least for me, what the argument is saying. Okay, but see, the problem is when you look at the argument from the point of view of an ultrafilter, that for any set, okay, there's not just one ultrafilter on the set. So we'll actually go into this in a later video. We're just trying to get a summary of it. So I'm trying to give you a bit of a punchline ahead of time, but there's many principal ultrafilters on a set. Okay, so what that means is that there are many ways that you can define the notion of a positive property. Okay, so there's basically one notion of positive property for every principal ultrafilter of the set. Okay, but once you have an ultrafilter and once you've defined what positive means, right, then you can actually prove all principal ultrafilters are basically there's one for each element of the set, basically. So it uniquely defines one element of the set, and that'll be your godlike being. So not only does that godlike being exist, it'll be unique, okay? But the problem is there's a different godlike being for every different notion of positive you come up with. So for every different ultrafilter, there's a different element of the set, which that ultrafilter corresponds to. So it's actually a really ingenious thing because it takes this argument, which is sort of almost incomprehensible, but kind of very interesting, and it makes it so precise that you can actually prove something. Okay, but the problem is it doesn't exactly quite prove the thing. Well, it might prove the thing you want, but the difficulty might not be proving it they exist in something. It might be the definition of the positive property. So it really says if you have to choose a definition of positive property before you can find this godlike being, okay, and basically for every being in your set, there's actually a choice of positive property for which that being is the god-like thing. Okay, so that's kind of like the problem in the end, but it's a very interesting investigation, and it would be very illustrative um, to learn the logic behind that. You know. Okay, I have to go, so I'm gonna stop it here.